7,500 years ago, the Pacific floor collapsed. Massive landslides buried the seabed in seconds. Fast forward to today, robot subs have examined the place. Scans have revealed proof of at least 10 distinct cyclical mega-quakes. Now, researchers warn, the plates are still locked and building pressure, even today. If they start moving, that could trigger new red alert earthquakes and send disastrous tsunamis toward the coast. Let's look at the map. The fault here is like a giant zipper. It's over 600 miles, stretching from northern California to Canada. It's called the Cascadia subduction zone, and it's a part of the Ring of Fire. You know, the famous giant horseshoe around the Pacific that can serve as your where-to-go reminder if you're into volcanic and earthquake tourism. One of Cascadia's biggest events happened around the year 1700. There are no local written records of it, but there is a story. A well-known indigenous legend tells of an epic battle between a thunderbird and a whale. In the story, the thunderbird's wing beats make the ground shake. The whale's thrashing sends seawater flooding inland. The thunderbird wins by finally grabbing the whale and slamming it back down, shaking the land itself. Many researchers believe that this legend originated from the real earthquake of 1700. But we don't just have cool myths to give us the full picture. In the early 1700s, samurai officials recorded waves flooding villages and rice fields. But nobody felt the earthquake that must come first. That's why they nicknamed this event the Orphan Tsunami. But it did have a parent, and it took scientists 300 years to finally connect it back to Cascadia. To see Cascadia's past, researchers sent robot subs to scan the bottom in crazy detail. They expected to see a simple crack, but what they found looked more like giant underwater steps. Some of those steps are about 33 feet tall, like a 3-story building. That only happens when a big piece of the seafloor snaps off, breaks loose, and slides all at once, not slowly. When that happens, it kicks up a mud avalanche. Picture a jar of dirt and water. Shake it hard, and a fresh layer settles at the bottom. Each layer is basically a timestamp from a huge quake. When scientists counted and dated them, they found 10 separate mega-quakes that hit one after the other over thousands of years. That means that Cascadia doesn't let pressure out little by little. It stays stuck for a long time, then suddenly breaks out violently. That pattern is why the Cascadia subduction zone is considered one of the scariest fault systems in North America today. So what's actually happening down there? The plates aren't sliding smoothly, they're stuck. And while they're stuck, the coastline is getting quietly bent out of shape, like a ruler you're flexing in your hands. It doesn't look dramatic day to day, but it's been loading up for centuries. When that tension finally snaps, the coast will instantly drop. Geologists call this co-seismic subsidence. We're talking about the ground plunging 6 to 8 feet vertically in a matter of minutes. Imagine standing on a beach. The shaking stops, and you realize the ocean is rushing in. Not just because of a wave, but because the land you're standing on has physically sunk below sea level. That one move is enough to shove the seafloor out of position and force the ocean above it to react. Cascadia can produce a magnitude 9.0. That's top tier, categorized as the most destructive natural event that can happen. It can shake the ground for minutes, pushing and pulling everything back and forth until buildings and bridges start falling down. A 9.0 class quake also means the seafloor is vibrating and shifting, lifting in some spots, dropping in others, all in one sudden motion. A tsunami starts when the seafloor moves and pushes a huge amount of water out of the way. If the bottom suddenly lifts or drops, the water above it gets displaced instantly. That water has to go somewhere, so it races outward in every direction. Out in deep water, that wave is rarely tall. It spreads out across a long distance, so it can pass under ships without anyone noticing. The danger is speed. In the open ocean, tsunamis can travel around 500 to 600 miles per hour. That's like traveling from New York to Detroit in 60 minutes. Eventually, the ocean starts to pile up, getting taller by the second. Near shore, it can stack up to tens of feet, and in extreme cases, it can run up to 100 feet on land. It swallows the coast, then drags everything back to sea with a violent tug before the next hit arrives. But that's not all. When the fault snaps, it often triggers massive underwater landslides. When a huge chunk of seafloor collapses, it can shove water locally, like dropping a boulder into a tub. In the Cascadia subduction zone, you aren't just dealing with the earthquake's kick. You're getting a 1-2 punch from the shifting crust and the crumbling slopes combined. On parts of the Oregon coast, emergency experts say the shaking could last 5 to 7 minutes, long enough to realize what's happening and still won't be over. Then comes the scariest part. In some places, a tsunami can hit in 15 to 30 minutes. Remember, the earthquake is a warning. If you're on the coast and you feel strong, long shaking, you do not need to wait for a text alert or a siren, or someone on the news to yell tsunami. During the tremors, the basic recommendation is to literally drop to the ground, cover, and hold on, staying away from windows and chandeliers that can fall on you. As tempting as it is, we shouldn't stop to make a reel out of the situation. Before anything happens, make one decision while your brain is calm. Pick the closest high ground and go for it. Not somewhere uphill, an actual spot. If you ever needed a reason to learn your neighborhood, this is it. Your instinct might say, get into the car and drive. But don't. Roads are probably jammed and bridges could be damaged. People who live on the coast already know to keep it practical, with shoes on the bed and a go bag prepared just in case. The danger doesn't end with the first impact because the tsunami waves, well, they come in waves. The initial hit is rarely the largest, and the ocean can continue to pulse in and out for hours. This creates a violent tug-of-war. The receding water acts like a massive vacuum, dragging anything caught in the backwash out to sea. Japan's 2011 disaster is the most recent vivid example of what a magnitude 9.1 can do. The seafloor shifted in a single massive heave, and minutes later, the ocean literally rearranged the coast. A huge wall of water crashed inland, reaching over 100 feet high in some spots, and turning the coastline into a conveyor belt of debris. It was like water turned cars into giant bowling balls and shipping containers into massive metal bricks, smashing ports and drowning low-lying airports and electrical substations. Finally, what do officials say about the timeline for the possible next disaster hitting Cascadia? Well, they can't give us precise dates, but they did announce some odds. For the biggest, scariest earthquake possible, the United States Geological Survey says there is about a 10% to 15% chance it'll happen in the next 50 years. Chances for a quake that isn't the mega version are 1 in 3 in the next 5 decades. Those odds are actually pretty high. But here is why it isn't all that grim. Scientists know this isn't random. Cascadia has a pattern, and patterns are what preparation runs on. We already know how to build for big shaking, and we're getting better at spotting where stress is building. It doesn't mean we can stop the earthquake, but it means we're getting way better at knowing what to expect. In the meantime, just keep a go bag by the door and maybe take a walk around your neighborhood every once in a while. Imagine standing in a quiet northern town, surrounded by mountains and forests, when the ground beneath your feet suddenly shifts with the force of a freight train. That's not a movie scene. It's a very real possibility for the people living in Dawson City, Canada. Hidden beneath the tranquil Yukon landscape lies a geological giant, the Tintina Fault. For more than 12,000 years, it has been silent, but new research suggests it might be ready to wake up in a spectacular and dangerous way. Stretching over 1,000 kilometers from the Yukon into Alaska, the Tintina Fault is like a massive crack in Earth's crust. a boundary where colossal slabs of rock slowly grind past each other. On the surface, it looks harmless, just rugged terrain, rivers, and forests. But deep underground, strain is quietly building, like a spring being wound tighter and tighter. Theron Findlay, a geologist from the University of Victoria, and his team decided to take a closer look at a section of this fault near Dawson City. This wasn't just a casual inspection. They used cutting-edge tools like high-resolution satellite images, aerial surveys, and LiDAR, a laser-based scanning method that can reveal subtle changes in the ground's shape. What they found was unsettling. In one location, the ground was visibly displaced by an astonishing 1,000 meters, evidence of a long series of powerful earthquakes millions of years ago. In another area, they spotted a smaller but still significant offset of about 75 meters, likely caused by more recent quakes, roughly 132,000 years ago. Since then, nothing major. At least, nothing visible. And that's exactly the problem. When a fault line hasn't released energy for thousands of years, it doesn't mean it's safe. Quite the opposite. It could mean that massive pressure has been silently accumulating. Based on their calculations, the Tintina fault has been moving at a slow creep of up to 0.8 millimeters per year. Over 12,000 years, that adds up to a staggering 6 meters of potential movement waiting to be unleashed. If that strain were to suddenly break free, the resulting earthquake could be bigger than magnitude 7.5. For context, that's in the same league as some of the most destructive quakes in history, like the 1976 Tangshan earthquake in China, or the 2010 Haiti disaster. While the Yukon isn't densely populated, the impact could still be devastating, damaging highways, collapsed buildings, landslides cutting off communities, and potentially loss of life. The scientists can't say when it will happen. Earthquakes don't work on a schedule, and predicting the exact moment of rupture is one of geology's greatest challenges. What they do know is that the Tintina fault is in what's called a late stage of its seismic cycle, a point where the risk of a major quake is higher. For the people of Dawson City and surrounding areas, this means living with a quiet but ever-present threat. Emergency planners might advise residents to have evacuation routes, survival kits, and backup communication plans. But in the end, this is a reminder of a simple truth. Earth is never truly still. Even in the most peaceful landscapes, immense forces are always at work, reshaping the planet in ways we can't always see, until the day they reveal themselves with a violent jolt. Yet, the story of the Tintina fault is more than a warning. It's a glimpse into how Earth stores and releases its pent-up energy. Each millimeter of annual movement is like another twist of a key in a lock. At some point, the lock will turn, and when it does, the release will be sudden and powerful. LiDAR images reveal ancient scars across the land, subtle to the untrained eye, but obvious to scientists. These are the footprints of past disasters, frozen in the ground like a history book carved by nature. Findlay and his colleagues believe the region's seismic silence has lulled people into a false sense of security. A place can be both beautiful and dangerous, and the Yukon is a perfect example. Visitors come for the sweeping vistas and endless wilderness, rarely realizing that deep beneath their hiking trails and scenic roads, forces are shifting that could change the landscape overnight. This hidden drama plays out all over the world. Fault lines in California, Turkey, Japan, and beyond all share one trait. They eventually break. The question is never if, but when. The Tintina fault just happens to be one of the quieter players, which in geological terms can be far more ominous than the noisy ones. And so, the clock ticks, silently, in the frozen north, counting down to a moment no one can see coming. Something is about to reshape the entire future of the West Coast. The coastline, the infrastructure, the whole map. Scientists fear there is not one but two big earthquakes coming, one caused by another. This wasn't even on the radar for most people, but new research is changing everything. For decades, everyone treated the San Andreas Fault and the Cascadia subduction zone like two separate monsters that just happened to live in the same neighborhood. They were powerful, yes, but independent. But now, scientists believe these two giant faults are mechanically linked, and one can literally pull the other into rupturing shortly afterward. Cascadia moves, San Andreas moves. San Andreas tears, Cascadia tears. And the potential consequences of that are honestly haunting. Scientists found evidence that it happened at least 10 times in the last 3,100 years. Earthquake, pause, earthquake. It comes from marine sediment cores, which are like time capsules pulled up from the ocean floor. Researchers analyzed layer after layer of seabed sediment and found doublets. Paired debris layers created by two massive quakes happening so close together that the ocean barely had time to settle between them. That discovery takes us to the Mendocino Triple Junction, the geological troublemaker of the West Coast. It's the place where three tectonic plates crash and grind into each other like badly aligned gears. It's also the zone where the San Andreas meets Cascadia, which makes it the perfect place for these double quakes to form. The stress changes caused by a rupture in one fault travel straight through this junction and destabilize the other. It's benign when it happens to a bookshelf. When you move one book, three others shift. But when you think about it like a coastline with millions of people, entire cities, major infrastructure, it instantly feels terrifying. To many people who live on the West Coast, the San Andreas kind of feels like a California's problem, and Cascadia like an Oregon and Washington's problem. But when you understand that these two faults can essentially fire at each other, it stops being a local issue and becomes a continental one. A Cascadia megaquake alone can hit magnitude 9.0 plus, rip open 600 to 700 miles of seafloor, and send a tsunami roaring toward the Pacific coast. And it could just be the first quake, and then, maybe minutes later, the San Andreas snaps in Northern California. The shaking could ripple down the state like a zipper tearing open a jacket, and if it goes the other direction, it could be just as bad. If the San Andreas ruptures first, the intense stress redistribution can destabilize the Cascadia subduction zone. You could get the California quake first with buildings rocking, highways breaking, and power stations failing. And then, soon after, the ocean pulls back in Oregon or Washington. And the 20-minute countdown to a tsunami begins, a follow-up disaster. It's the kind of chain reaction you don't want even in a video game, let alone real life. This discovery also tells us something eerie about the earthquake in 1700. The one that sent a tsunami across the Pacific so huge that it struck Japan with no warning. Japanese fishermen called that wave the orphan tsunami because it arrived without any felt shaking. Only centuries later, scientists figured out that it came from the Pacific Northwest. But until recently, no one knew that the San Andreas might have felt that event too, and it possibly slipped or destabilized because of it. So, the whole West Coast may have moved together. And we've come to the scariest part. All this isn't about if, it's strictly about when. The faults have a rhythm, a pace, and a geological heartbeat. We've seen how they behave across thousands of years. We know what they did, and now we know they sometimes do it in sequence. The real fear isn't the first quake. California already expects a big one. The real fear is the second quake, the one that comes before you've checked on your family, before emergency responders regroup, before the power comes back, and before the dust settles. Even if you don't live on the West Coast, this matters for you too. The ports in California, Oregon, and Washington handle a massive chunk of America's imports. Knock them offline, and it's not just the coastline that feels it. The ripple hits the entire country, and potentially the world. Grocery prices spike, supply chains freeze, gas availability dips, shipping timelines go nuts. The world is much more connected than any of us thought, and a geological double punch on the Pacific coast wouldn't stay a local disaster. It would spread, thread by thread, into everyone's life. So, those in power must prepare not for one giant rupture, but for two. Emergency plans, evacuation routes, response times, and power grid designs. all of it needs updating. Because nature has now shown us what even a single major rupture can do to a modern economy. It happened in Japan in 1995, on January 17th at 5:46 in the morning. The quake hit right by the northern tip of Awaji Island, only 12 miles from Kobe, a huge, busy city with about 1.4 million people back then, and another 2.6 million in Osaka nearby. The rupture ripped along the Nojima Fault for about 25 miles. That doesn't sound like much until you realize entire buildings can't survive that kind of sideways shove. More than 5,000 people lost their lives. 43,000 were injured. Nearly 400,000 buildings were irreparably damaged. This disaster hit one of Japan's largest industrial zones. And when you mess with a place like that, the shock doesn't stop at the shoreline. The damage was $200 billion US in losses, from smashed buildings and infrastructure and many businesses shutting down. Kobe's port just collapsed. Only 30% of the Osaka-Kobe railway lines worked. Part of National Route 28 literally vanished into the ground. Schools, hospitals, and municipal buildings, 85% of them took damage or were unusable. Fires broke out across Kobe, almost 300 separate incidents, burning the equivalent of 70 US city blocks and taking another 600 to 700 lives. Almost 100,000 people permanently left the region, 2.5% of the whole population gone in less than a year. And here's a detail that stuck with me. So many bridges failed that engineers suddenly had to confront how poorly older designs handled lateral shaking. Houses with heavy tiled roofs, built to fight typhoons, crumbled because all that weight sat too high. But the newer homes made after the 1981 building code revision stood. And that's when Japan realized that modern seismic standards were crucial to follow. Japan threw $58 billion US into restoring the region. Power came back in days. Roads and rail returned in 5 to 8 months. The main expressway took 21 months. The port was fully rebuilt in just over 2 years. And by then, all debris was cleared. Within 15 months, manufacturing jumped back to 98% of its old level. Stores reopened. By 1999, Kobe's economy reached roughly 75 to 90% of pre-quake levels. Japan overhauled its disaster management system entirely. They set up the Central Disaster Management Council and rewrote building codes. They upgraded everything from emergency drills to fire-resistant city layouts, and they launched the Earthquake Early Warning System that now gives Japan those precious few seconds before shaking hits. The same system that saved countless lives since 2007. But despite all this improvement, the Kansai region still sits on dangerous ground. The Roku-Awaji-shima fault system, the same one that snapped in 1995, still runs under them. The 2018 Northern Osaka quake and the 2024 Noto Peninsula quake reminded everyone that this threat didn't disappear. It just waits its turn. A future large event on that system could hit even harder simply because the region has grown more complex, more interconnected, and more economically loaded. So Kobe wasn't even a triggered double fault rupture, but it still broke a major industrial hub, reshaped a national economy, and permanently changed global shipping routes. That's why when scientists started talking about two joint faults firing off back-to-back in Cascadia and San Andreas, you don't even have to imagine the consequences. We already got a preview in 1995. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash, but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day, and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientists in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below. And the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tahoe. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something it can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
The floor is lava. Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help." Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level. And a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first. We know more about space than we do about the ocean. We know more about the ocean than we do about the Earth's core. But how do we study something that lies more than 1,000 miles beneath our feet? Oddly enough, you need to fly into space. Thanks to satellites orbiting the planet, scientists have discovered something strange at the very heart of the planet. News about mysterious signals from space barely surprises anyone, but how about this? We detected strange signals coming from deep beneath our own home. Before we go into those signals, we need to understand why it's so important to study what's inside the planet. How does the core affect us? Our lives depend on it in several crucial ways. First, the core plays a fundamental role in gravity. We don't drift off into space because a massive spherical mass of molten metal locks us to the surface. Second, it powers Earth's magnetic field. Dangerous cosmic radiation and solar wind that could scorch everything are blocked thanks to the planet's magnetic field. And third, the inner processes of the Earth influence earthquakes and volcanic eruptions. Any disturbance inside the core and mantle can change life on the planet. And recently, scientists recorded something unusual coming from down there. At the beginning of this century, the United States and Germany launched a mission called GRACE, the Gravity Recovery and Climate Experiment. At first, this project used 2 satellites to track how water moved around the planet and how glaciers were melting. But the satellites could also measure Earth's gravitational field. If gravity was slightly stronger or weaker in some region, one of the satellites would be pulled toward that spot, and the other would measure the change in distance. In very simple terms, the heavier something is, the stronger its gravitational pull. In certain parts of the planet, gravity can be slightly higher because of large geological shifts, ocean currents, or melting ice. But between 2006 and 2008, the GRACE satellites detected a strange change in gravity along the coast of Africa. Melting ice, water movement, and other natural phenomena couldn't explain the anomaly. No one knew what it was at the time, but years later, scientists suggested that the nature of this signal was coming from the Earth's core. Researchers noticed that some minerals, like perovskite, can undergo a phase transition when exposed to enormous pressure and extreme heat. And there are many perovskites lying in the upper layers of the mantle. When the internal structure of this mineral reshapes, it becomes denser and shifts the surrounding rocks. Deep underground, this harder, solid part moves the softer molten rock. These movements reach the molten outer core and slightly deform it. This deformation inside the core alters the flow of molten iron, and this deep current of liquid metal directly affects Earth's magnetic field. That's why satellites recorded those fluctuations. So how does all of this affect us? We launch satellites, we use compasses, we rely on GPS. All of this works only because gravity and the magnetic field are stable, and both depend on the core. That's why it's so important to study the Earth's heart. And to do that, we don't need to dig thousands of miles. Movements on the surface can reveal what is happening inside. Studying vibrations in the crust, recording gravitational shifts, calculating, modeling, and forming hypotheses. It all sounds a little boring. Is there another way to figure out what's happening down there? We sent Voyagers into space, and some of them have already left the solar system. We descend into the depths of the Mariana Trench inside bathysciphs. So what's the problem with drilling a shaft deep into the Earth's crust? Humanity actually has some experience with this. In the 1970s, Soviet geologists began drilling the Kola Super Deep borehole. It became and remains the deepest artificial borehole ever created. Its depth reaches 7.6 miles, deeper than the Mariana Trench and higher than Mount Everest. More than 50 years have passed, and humanity has not gone deeper than 7.6 miles. And do you know where the Earth's core begins? At about 1,800 miles down. That's almost 7 times farther than the distance to the International Space Station. To reach the core, we would need to drill a hole 230 times deeper than the Kola Super Deep. But that project was shut down in 1992, and the borehole was closed in 2005. What stopped us from digging deeper? First, the density of the rock. In the early stages, the drill easily cut through granite, but around 4.3 miles down, the rock became much harder. The drill broke several times. Workers had to change the drilling direction to pass through softer layers. Eventually, the borehole shape looked like a string of lights hanging on a Christmas tree. Another problem was heat. The deeper the engineers went, the hotter it became. Scientists expected that past a depth of 10,000 feet, the temperature would be around 212 degrees Fahrenheit. In reality, the harder they worked, the worse it got. Eventually, it reached 356 degrees Fahrenheit. The hottest place on Earth is the Sonoran Desert along the Mexican-US border. Temperatures there can reach 177 degrees Fahrenheit. That's twice as cool as inside that terrifying borehole. And the challenges did not stop there. At a depth of about 14,800 feet, the rock became porous. The extreme heat gave it a strange plasticity. Instead of solid stone, the drill had to cut through something more like hot, softened material that was almost impossible to drill. On top of that, the stability of the shaft became a danger. At such depths, the walls could collapse at any moment. To drill deeper, humanity would need completely new technology, a drill capable of working at 500 degrees Fahrenheit. That is the temperature scientists expect in the upper mantle, located just beneath the crust. And to reach it, we would need to drill 25 miles down, almost 3 times deeper than the Kola Super Deep. There are many rumors about what the engineers supposedly discovered in that hole. The most popular claim is that they heard the screams of thousands of people who were stuck in the fiery underworld. Other fake stories claim that the workers went insane after seeing something horrific at the bottom, and that's why the project was stopped. But if we ignore these myths, what did scientists actually find? They learned that the existing temperature model of Earth's interior was wrong. It was far hotter down there than expected. Geologists thought they would find the so-called Conrad discontinuity, a transition from granite to basalt. They found no such boundary. The real discovery was a liquid at incredible depths. Scientists found cracks filled with briny water. This changed our understanding of the crust. People used to believe it was completely solid, but now it appears full of fractures and channels through which water can move. Where did it come from? Geologists think the fluid was squeezed out of the rocks by enormous pressure, as water is wrung out of a sponge. But the most astonishing discovery was life. At about 4.5 miles down, engineers found ancient fossils of single-celled marine organisms. They were nearly 2 billion years old, and they had survived at such extreme heat and pressure. Let's imagine that one day we actually reach the mantle. What would that give us? What would we expect to see? We would finally understand how Earth formed billions of years ago, how the core, mantle, and crust developed, and how plate tectonics works. We'd know how the plates push and pull against each other. We'd gain a deeper understanding of earthquakes. Researchers also hope to find extremophiles. These are primitive organisms that can withstand extreme heat and pressure. If we discover life near the mantle or even within it, scientists will study it closely and try to understand how it manages to survive under such brutal conditions. If we learn what keeps life alive in the most hostile environment beneath our feet, we might learn how to protect life in other extreme places, from the depths of the ocean to distant planets. Studying the heart of our planet could reveal technologies we can barely imagine today. Our future might depend on the mysteries hidden beneath our own world. Roofs fly off like paper. Huge trees are yanked from the ground. Power lines snap and leave neighborhoods in the dark. Streets flood like rivers. Homes are left in ruins. That's a hurricane passing through. After the wind calms down, the real mess begins. People stranded, no clean water, destroyed roads. Storms have been picking up for like 5,700 years. And the scariest part is that in the last 20 years, there's been a huge spike. But let's start from the very beginning. This is Belize, a small country on the northeastern coast of Central America. And this is the Great Blue Hole. A huge, deep underwater sinkhole about 410 feet deep and approximately 50 miles off the coast of Belize. It formed around 10,000 years ago when the sea levels rose after the last ice age. A team of scientists arrived in Central America to study mud from way down in the Great Blue. They pulled out a long sample of sediment, which is basically layers of stuff that's settled over time. You might ask, so what? How are tropical storms connected with this sediment? Let's see. Tropical cyclones are big, spinning storms that form over warm ocean water. They pull up heat from the sea and blast it into the sky. And yeah, they can be devastatingly destructive, with super strong winds, heavy rain, and floods from big waves. And mud cores like the one the researchers pulled up are actually records of tropical storms. The sample they pulled up was 98 feet long, which made it the longest ever found in that area. Here's how it works. Every year, two thin layers of sediment settle in the hole where the weather is calm. But when a big storm hits, it leaves behind a different, messier layer. So by looking at these layers, scientists could tell how many storms hit that spot over the last 5,700 years. It's like counting tree rings, you know? Anyway, what they found was rather unexpected. It turns out that tropical cyclones had been getting more and more common. The lead researcher said that over the past 6,000 years, there were usually between 4 and 16 tropical storms or hurricanes every 100 years. But just in the last 20 years alone, they found signs of 9 storms in that same little area. That's way more than usual, and it shows how much things are changing. Scientists think there are 2 main reasons why tropical storms have been happening more often. One reason has to do with something called the Intertropical Convergence Zone, or ITCZ. This is an area near the equator where winds from the north and south come together. That spot has low air pressure, lots of moisture, and tons of thunderstorms. Just above it is the part of the Atlantic Ocean where most hurricanes are born. It even has an official name, the Hurricane Main Development Region. Normally, the ITCZ moves north in the summer and south in the winter because of changes in ocean temperatures. But over the past few thousand years, it's slowly been shifting farther and farther south. That's why the area where storms usually start has also moved south. It means storms are now forming and heading toward lower parts of the Atlantic than they used to. The second reason for the recent spike in storms is rising ocean temperatures. Earth has gotten warmer, and the ocean has warmed up too. The warm oceans help make more powerful storms. Such an increase likely means that this part of the world might see a lot more big storms in the future. If things keep going the way they are, scientists think the Caribbean could get hit by as many as 45 tropical storms and hurricanes by the end of this century. That's way more than anything the world has experienced in the last 5,700 years. There are just too many changes in the world that influence the situation. They create the perfect conditions for more storms to form and get really intense really fast. But if you think storms are getting more intense only over the ocean, let me tell you about America. A bunch of really dangerous storms, including tornadoes, dust storms, and wildfires, tore through several states in the Midwest and south of the USA in March 2025. At least 42 people lost their lives, and the scale of the devastation is enormous. What's scary is that most of this destruction didn't happen in the usual Tornado Alley area. Tornado Alley is a nickname for a part of the US where tornadoes happen a lot. It stretches through places like northern Texas, Oklahoma, Kansas, Missouri, parts of Louisiana, Iowa, Nebraska, and even eastern Colorado. But this time, storms hit places like Mississippi, Arkansas, and Alabama. Experts had warned this might happen. At the beginning of 2025, they said that tornadoes could start showing up more often farther east than usual, and that's exactly what's happening. One of their top weather experts said people in the Mississippi and Tennessee valleys should get ready for a rough spring. There are more people living in these areas than in traditional tornado zones, and many of them live in mobile homes or buildings without basements, which puts them at more risk when big storms hit. A tornado is basically a spinning tube of super strong wind that comes down from storm clouds and touches the ground. They can be really dangerous. To figure out how strong a tornado is, scientists use something called the Enhanced Fujita scale. It goes from EF0, which stands for the weakest tornado, to EF5. Such a tornado is crazy strong, tear your house apart strong. The main question is, why are tornadoes happening more in the east now? In the US, tornado season usually kicks off in March. That's when cold air from Canada bumps into warm, wet air coming up from the Gulf of Mexico. And boom, storms start to form. But this year, things are a bit different. Here's what's going on. There's a big patch of high pressure, basically a chunk of calm, warm air hanging over the southwest. That's keeping things more stable out west, so fewer thunderstorms as well as fewer tornadoes are expected there. So, tornadoes are shifting eastward. Meanwhile, the Gulf of Mexico is super warm this year, and that's helping storms form in the southeastern US. The warm water adds a lot of energy to the atmosphere, which can lead to stronger, more frequent storms in places like Mississippi, Alabama, and Tennessee. Up north, around the Great Lakes and Northeast, it's staying cooler this spring. That means fewer big storms up there, at least for now. Now, let's get back to those devastating March storms. On March 14 and 15, a huge storm system blasted through parts of the central and southern US. This system brought 52 confirmed tornadoes, massive dust storms, and fast-moving wildfires. It all led to almost 1,100 canceled flights. About 150 million people were affected by this natural disaster. Two really strong tornadoes classified as EF4s hit Arkansas. The damage was incredible. One of those tornadoes, which hit a town called Diaz, had winds up to 190 miles per hour. That's insanely fast. For comparison, the average speed of a Formula One car is around 130 to 160 miles per hour. It was the first time in over 25 years that Arkansas got hit by two EF4s on the same day. Experts also recorded wind gusts moving at a speed of over 80 miles per hour in the southern plains. In Texas, dust storms led to fatal car crashes. Wildfires, caused and driven by the strong winds, burned through parts of Texas and Oklahoma. Oklahoma alone had more than 130 fires. So, what's next? Experts think the US could see between 1,300 and 1,450 tornadoes in 2025. That's way more than the usual 1,225. And it's not just about tornadoes. A warmer atmosphere can hold more moisture. That means heavier rains, more flash floods, and even more powerful storms. Basically, the formula is the following. Warmer oceans plus warmer air equals stormy weather, especially in the east and southeast. But even if you don't live in any of these areas, you can't feel completely at ease either. Experts say tornadoes and other natural disasters can happen pretty much anywhere in the US. The risk moves around depending on the time of year and the weather.
Do you know that our planet has scars? One of them is located in North America. This scar can tell us many cool things about the history of Earth, but the most interesting thing is that it could change the appearance of our continents and break our world. But for some reason, this scar hasn't done it yet. And that's not even the most interesting part. The coolest thing about this scar is that it might hold a giant source of clean, cheap energy. So let's go to Kansas to find out what it is. So, 1.1 billion years ago, a giant rift formed in the crust of our planet on the territory of the modern U.S. Midwest. It's called Broken Heart. This giant crevice is filled with solidified magma, and from afar, it looks like a real scar. But how did it show up? Broken Heart was an ancient rift valley, a huge geological fault forming elongated hollows in the Earth's crust. It occurred because tectonic plates had moved apart. It's like the details of a jigsaw puzzle that suddenly started to separate. At that moment, thousands and even millions of tons of magma spilled out from the depths of our planet. That event looked like a real apocalypse, lasting about 100,000 years. But then it stopped, and scientists don't know why. If the rifting process had lasted longer, then most likely the continent of North America would look different today, or it wouldn't even exist at all. Right now, this fault looks like a giant horseshoe that stretches from Kansas north to Lake Superior and south to Michigan. But some studies indicate that the fault may be larger and extend even further south, and the width of the fault might equal the width of the Red Sea. After the rifting stopped, the entire valley got covered with hills and trees. The fault itself is covered with a thick layer of sedimentary rocks, so it's quite difficult to track. The most noticeable parts of the rift are in the Lake Superior area. Now everything looks calm and beautiful, but in the past, there were fountains and rivers of lava, earthquakes, a boiling pot on a planetary scale. All that remains of it are deposits of basalt, a dark, dense rock that forms from cooled lava. There was so much basalt that its weight pushed the valley deeper and deeper into the Earth's crust. Even when the eruptions and rifting stopped, the valley continued to sink because of the huge mass of this sediment. Then, massive sections of the Earth's crust on both sides of the valley began to contract, and the pieces of the puzzle slowly started to come together. This led to a large-scale ejection of volcanic material upward, and along with basalt, deposits of copper rock appeared in the valley. People mined this copper for about 8,000 years until the end of the 20th century. The copper mines were eventually shut down, but now it seems the industry is making a comeback. However, Broken Heart is not interesting to people just because of its copper reserves. It holds something more valuable and useful for our civilization. Scientists believe that this valley hides massive reserves of hydrogen, and this substance can help us switch to a cleaner, cheaper, and more efficient energy source. If hydrogen fuel becomes widely available, everyone will switch to it, leaving behind the costly, noisy, and polluting process of oil production. Now, I'll bet hydrogen is a remarkably familiar word to you. It doesn't sound like the discovery of the century, and people have been using it for a long time. On one hand, you're right, but not quite. 90% of the hydrogen produced by humans is used as a raw material for the chemical industry. Hydrogen is used to produce ammonia for fertilizers, methanol for fuel and solvents, and to purify crude oil. Manufacturers of glass, cement, steel, and other metals are considering using hydrogen at their factories for more efficient production. Hydrogen can become an alternative to fossil fuels, that is, oil and gasoline produced from them. Cars, ships, trains, airplanes, and power plants, all of these may switch to hydrogen soon. In this case, production can become cheaper and better for nature, but this will work only if we find open sources of hydrogen. You see, about 95% of the hydrogen we use is produced from fossil fuels. We gasify coal, oxidize hydrocarbons, and extract hydrogen from methane. All of these production methods require energy. But the worst part is that they lead to large emissions of carbon dioxide into the atmosphere. But what if we find sources of pure hydrogen that don't require processing? Then we'll save energy for its production and make the planet cleaner. But where can we find such sources? Scientists say that there are many of them all over the planet, and one of the largest is located in the Rift Valley in the U.S. Midwest. But what's the problem with going and mining it? Well, it's not that simple. To extract pure hydrogen, you need 3 conditions. The first is the source of hydrogen itself, which is quite logical. The second is reservoir rocks, that is, natural containers where this hydrogen is stored. And the third is natural seals, which prevent the gas from escaping. In other words, these seals work like a cap on a bottle. They don't allow the substance to escape. So in general, it's necessary to find where hydrogen is released, where it accumulates, and where it's stored. When these conditions are met, natural resource extraction companies can start working. But how does hydrogen appear altogether? Well, let's go over the basics of chemistry. Hydrogen and oxygen compounds form water. This means you need to split the water into hydrogen and oxygen. This process often occurs in nature. There are many places all over the planet where this happens. Scientists are confident that at least 30 U.S. states have hydrogen reservoirs, and if people detect them, we will accelerate the energy transition to safer and more efficient fuels. Thousands of cars drive around using gasoline. Many of you know the smell of exhaust fumes, that thick polluted air that's hard to breathe. What about electric cars? They must be improving the situation, right? Well, here's another problem. Producing batteries for these vehicles harms nature. The materials used to make batteries are lithium, cobalt, and nickel. Their extraction involves a large release of toxic materials, not only into the air but also into the water. Transporting these batteries also creates a large carbon footprint. Producing a single electric car emits about 4 tons of carbon dioxide. To make up for that, the owner needs to drive it for at least 8 years. That's how long it takes to offset the emissions a regular car would produce. What about reliability and convenience? What will you do if the battery runs out during the trip and there are no charging stations nearby? This problem will be solved in the future with the growing popularity of electric cars. Now, scientists believe that over the past billion years, the Earth's crust has split enough water into hydrogen and oxygen. Our planet keeps this gas in the ground, waiting for us to start using it. According to calculations, even considering all the technologies and production capacities of our civilization, the reserves of hydrogen in the bowels of the planet are enough to supply us with energy for 170,000 years. That's why the giant rift in Kansas attracts scientists from all over the world. Huge quantities of basalt and other rocks can react with water to release hydrogen. And now scientists are looking for places where this material accumulates and is stored. So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas fault line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas fault line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tahoe. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the U.S. around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis, but there's something it can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with. since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.